Hello, welcome to our patient education, public education conference series, summer 2020. We're going to talk about brain inflammation, stress and inflammation, things that happens to people's brains. And this is me. If you're new to all this stuff and you haven't been to one of these presentations before, this is Dan Kalish. Thank you for showing up. I have all kinds of different roles in the world these days. I teach for the Institute for Functional Medicine. We have a collaboration with them for their practice implementation program. Basically, I teach doctors how to set up functional medicine practices, teach business practices, but mostly I teach advanced lab interpretation and functional genomics and that kind of stuff. I've done some research with this somewhat amazing group of human beings at the Integrative Medicine Department at Mayo Clinic. Some folks I really love over there. We did a research study on the Kalish method to show that it worked scientifically. That took a year of my life. Right now, I'm doing the most exciting thing I've ever done professionally, which is work with Dr. Richard Lord. And we'll be coming out with a course. I think it's really primarily designed for physicians, but I think there's going to be a lot of interest in other people. It's going to be clinical nutrition and primary care, straight from Dr. Lord, who's the master of this field and really one of the amazing leaders in our industry. And then I'm in practice, and if you guys are interested in becoming a patient, you're welcome to sign up. We have slots open. I'll talk a little bit about that more later. And what I'm mostly interested in now in my practice is figuring out how to fix these complex problems that people have. Brain problems are frequent, and how to run labs and then make all these things work. So I'll just show you real quick. Here's what we're about today. Sorry, that's not showing up really well. Hang on, I'll make that better in a second here. And trying to figure out, honestly, this brain issue. So I'll give you a little bit about my history on this. So I've been running these labs for 28 years. I've been in practice, all these years, and I spent maybe 12 years focusing just exclusively on looking at brain issues. And during that time, spent a huge amount of time with doctors from all over the world. I was really fortunate and to be able to work with them and start to understand this from a deeper level. And I want to try to convey all that in about 20 minutes, see if we can pull that off. And I think the principles are pretty straightforward. And if you can see the bigger picture here, you can find a functional medicine doc to help you out. You can get these things put together. But it's certainly an area where we see a lot of confusion, and people suffering unnecessarily because they don't understand the dynamics. So there's a couple of different types of neurotransmitter imbalances. We're going to primarily talk about two of them today, but there can just be straight up neurotransmitter deficiencies because you're burning up too many of these chemicals, because you don't eat very well, because your digestion doesn't work very well, or because you're taking a bunch of medications that deplete neurotransmitters. Ironically, a large number of people are on drugs that deplete neurotransmitters. That could be cocaine, that could be Adderall, that could be Prozac, that could be methamphetamines, right? There's what we call recreational drugs, meaning that you buy them on the black market, like cocaine and methamphetamine, get you high. Those deplete brain chemicals pretty darn fast. But then there's prescription drugs that deplete brain chemicals pretty fast too. And if you're on a prescription drug that depletes brain chemicals, if you just take the right nutrients, that brain chemical depletion will be reversed. So you can safely take these drugs if you know what you're doing from a clinical nutrition perspective. If you're on cocaine or methamphetamine, you probably shouldn't take supplements, right? You should just stop being a drug addict. So that's a whole different question. But certainly for the prescription drugs, we want doctors to understand that, hey, if you're going to put someone on Prozac, that is totally fine. Just give them these 3 supplements, and the medication will have very few adverse effects. So then there's another category here, which is pretty dramatic and pretty sad, really, when you even think about it or talk about it, which is damaged neurons. So this means that there's something that impacted the brain negatively, something that is damaging or destroying neurons in the brain. And just like if you think about it like with a human being, if someone dies, does it really matter how they died? Kind of, but not really. So if someone's murdered, let's say, they were stabbed to death or shot to death, or someone blew up their car, someone threw them into a raging river. It doesn't really matter, right? So when your neurons in your brain are damaged, they're dying at a certain rate. And you can have death of a neuron from environmental toxin exposure. These are called neurotoxins that destroy the brain. And you can have damage from a neuron from physical trauma. Again, it doesn't matter. It's like the difference between being stabbed to death and shot to death. The neuron's dead either way. So physical trauma would be you're hitting your head against something. Hopefully not against a wall, but you're hitting your head against a car windshield because you crashed in a car. Or there's like 500,000 veterans that we have in this country now that have come back from the wars in Afghanistan and Iraq who have been driving around in their armored Humvee, and the Humvee was blown up by an IED. And they survive because we heavily armor these Humvees, and the troops are wearing Kevlar armor and all this kind of stuff. But their brains get jostled around pretty good. And a single explosion, exposure to a single explosion like that can cause some pretty serious physical trauma to your brain. And so we have all kinds of issues with head trauma, and we have a ton of issues now with environmental toxin exposure, any of which can cause these, okay? So just something to keep in mind as we're kind of marching through this in terms of your history or family member history. Do you have exposure to environmental toxins? Do you have exposure to physical trauma? Or is there some kind of stress issue that's pushing these neurotransmitters out? Now, in terms of symptomatic expression of this, like how do people feel? People gain weight and get tired when their brain's not working well. People don't digest well. They become, frustrated and depressed and anxious. Lots of different things can happen when that's going on. So I want to show you a little bit about some of the biochemistry behind this, and then a little bit about some of the potential corrections, and then maybe we'll have a moment and look at a little bit of the lab work. So there are, and this is one of those caveats where you don't want to try this at home. You definitely don't want to take an amino acid like tryptophan on your own. It just doesn't, it's just dangerous and risky. And, I wouldn't take it on my own, unless there was some doctor telling me what to do. So you don't want to self-treat with these things. And as you learn about them, if you think that you have the problem, you should do a consultation with someone like me. Self-treating is just going to get you into trouble. Because there's a lot of depletion that you can cause by self-treating inappropriately. In other words, if you take tryptophan or 5-HTP, you can deplete other brain chemicals. You might be feeling great in the short term, but in the long term, you're going to just end up digging a deeper hole for yourself. But you should know basic physiology here, so when you work with your practitioner, you have an understanding of what they're trying to do. So we get tryptophan in our diet, and tryptophan is an amino acid from which we make this brain chemical called serotonin. But tryptophan does a lot of other things. In fact, if you look at this chart real carefully here, this graphic, you'll see that 2 to 10% of your tryptophan is heading over to serotonin. And the vast majority of that is going to your gut. 95% is going to your gut. 4 to 6% is going to your brain. Okay, so let's look at that again. All the tryptophan that you're getting, let's say around 10% is going over to serotonin. Around 4 to 6, let's say around 5% of that's going to your brain. So it's 10% of 5% of something, right? It's a really, really small amount of tryptophan is actually getting into your brain. Mostly tryptophan is doing all these other really, really important things. Okay, and so when you start to take a supplement like tryptophan, you're causing changes all throughout the body, not just in your brain. So you have to be a little bit careful about how you do that. It can, however, work really, really well. If you're doing lab testing, you're tracking all this carefully, you can make a huge difference with people. And, it's very, very helpful. So anyways, this is some research on tryptophan. I won't bore you with that. But this is a basic pathway. And when we're talking about inflammation, a couple different things classically within functional medicine can cause inflammation. So the biggest area for potential inflammation would be coming from your gut. Your gut is inflamed if you're eating inflammatory foods, right? Every food that you put in your mouth is either pro-inflammatory, which means it's going to cause inflammation, or anti-inflammatory, which means it's going to reduce inflammation. So if you're eating a lot of pro-inflammatory foods, your gut's going to be inflamed, and that's going to eventually cause problems with tryptophan and potentially trigger inflammation in the brain. This is a whole gut-brain connection. So If you're gluten sensitive, which not everybody is, but if you're gluten sensitive, gluten will cause inflammation. If you're dairy sensitive, dairy will cause inflammation. If you're just anybody, all people, sugar will cause inflammation. Alcohol will cause inflammation. So there's certain bad stuff that we consume that can trigger inflammation. And then the anti-inflammatory foods are pretty famous. They're called vegetables. They're called fruit. They're called foods that have polyphenols in them. You know, curcumin. This is massive anti-inflammatory. You should probably all take curcumin every day. How do you do that? Just use turmeric in your cooking, right? You don't have to buy a supplement for that. So if you're using anti-inflammatory stuff like turmeric in your cooking and you're eating vegetables and fruit, then you're going to have a low inflammatory response and your brain will be much better protected. But many people eat a very highly inflammatory diet or they have gut infections that are triggering inflammation. And if there's that going on, then you have this very special thing called kynurenate, which goes up. And this is in the news a lot nowadays because we hear a lot about cytokines, right? When we're stressed or inflamed, the body's inflamed, then cytokine production goes up. This thing called kynurenate goes up, and that depletes our serotonin. So the more inflamed your brain gets, the less serotonin that you can make, and that can end badly quickly for some people. And we don't want that to happen, okay? So similarly, and I just want to show you this just to scare the pants off you so you don't try to self-treat, okay? So here's why you shouldn't self-treat. Because if you take a lot of tryptophan, it changes all these different enzyme reactions in the body. It's not just impacting serotonin, it's impacting your entire body, and you just don't want to do that, okay? You got to be a little careful. So, and this is an important slide to understand. So let's spend a few minutes on this. So if you're inflamed, maybe because you're eating the wrong foods or because you've got a gut infection, you're going to have an increase in these inflammatory products, INF, beta kappa, there's all these kind of fancy complicated names for them. And then that comes down here, and when your body's inflamed, you make this kynurenate, okay? And the kynurenate is made again from tryptophan. So you take this amino acid called tryptophan, you turn it into kynurenate when you're inflamed. Those numbers goes up and up and up and up. And eventually that causes this rise in something called quinolinate, and eventually that causes an excitatory response in the glutamate portion of the brain. So the glutamate is a neurotransmitter. It's the major excitatory neurotransmitter in the brain. And if you're really inflamed, the glutamate area gets stimulated, it gets stimulated by this stuff called quinolinate, which is generally considered neurotoxic. So inflammation generates this quinolinate, you get this neurotoxic reaction, and then your brain cells just kind of start jiggling, and then they jiggle, poof, and they start to pop. You know, that's maybe an over dramatization, but it's not a good thing, right? So you get this over excitation of the brain, and that causes people to get depressed or anxious or have all kinds of problems. It's exactly the same thing as if you, let's say you were playing basketball and you jumped up for the ball and you came down and you twisted your ankle and you're like, oh, this is not good. And you're going to go sit on the sidelines on the bench and you're looking at your ankle. It's getting all swollen and inflamed, right? That inflammation doesn't come from out of nowhere. Like you can see it when it's your ankle getting inflamed. And you realize, okay, this is swelling up. There's a bunch of fluid coming in there. You know, it's coming from somewhere. Your body's sending all these immune things to the ankle because it's worried about the injury. And so you're getting all this swelling and accumulation of fluid. That happens inside your head. You just can't see it. You're driving in your Humvee, you get blown up. You're in a car, you hit your windshield from a car accident, or you're eating a bunch of food you shouldn't eat. Your brain is getting inflamed. It's just like an inflamed and swollen ankle, but you can't see it. Okay, but there's not a lot of room in there, right? So as your brain starts to get inflamed, all these chemical reactions start to happen, and eventually it can lead to depression and anxiety and all these kinds of problems, and none of which are good, okay? And so as another effect of all that, let me show you here. I studied this for so many years, and there's so much to talk about, but it's almost like a simple story if I can really kind of boil it down. Let me show you just one more picture I want to show you here. This is a complicated lecture, but I just want to show you some of the highlights of it, okay? So another thing that happens when the brain is damaged, okay, this could be from a neurotoxin, this could be from physical trauma, something that's damaging the brain, is these really sensitive portions of the brain that are regulated by a chemical called dopamine. Okay, and what we see with most people that have environmental toxin exposure, I see this literally every day in my practice, literally every day I see this. You have a low dopamine person, they don't have enough dopamine, so they're anxious, depressed, tired, they can't sleep, they're compulsively overeating, they hurt all over their body, there's something really bad happening because dopamine's low, and they have really poor detoxification capacity, and their liver is just shot. Their liver is not able to clear all the toxins out anymore. Okay, and so when we're highly toxic, when we have these neurotoxins building up, these chemicals or heavy metals building up, dopamine seems to take a pretty big hit. The neurons that produce dopamine take a pretty big hit. Okay, and this becomes a central problem. Similarly, and here we see again, when you have this inflammatory reaction, again, these inflammatory cytokines are activated because you're fighting an infection or for some reason your body and your brain are inflamed, that's also going to deplete dopamine. So you can have this double whammy, right, where you've got a neurotoxin that's actually entering into your brain and damaging individual neurons. It's like if you walked into a pottery store where they're selling ceramics and you had a bunch of baseballs and you just start to throw them around the store and hit and break things. Yeah, it's like that. So when a neurotoxin gets inside your brain is surrounded by fat. It's not really designed to protect against neurotoxins. There's no game plan for that. So it's just like throwing baseballs or rocks in a pottery shop. It's just, instead of the glasses and plates breaking, it's neurons or brain cells that are being destroyed. Remember, it doesn't matter if you stab a person to death, you shoot them to death. If a brain cell is being destroyed by a neurotoxin, it's the same effect as if it's destroyed by physical trauma. It doesn't really matter. And so there's a decrease in the physical number of dopamine neurons when this happens. There's not enough of these brain cells to do stuff. And then on top of that, if you're also inflamed, then you're taxing the actual brain chemicals themselves. Okay, so it would be like if you had a car and you had someone who was shooting up the car with like a machine gun or something, right? And eventually the car is just not going to work because it's all full of bullet holes. But then at the same time, they're draining the gas from the car. So even if you could somehow miraculously drive this car full of bullet holes, there's no gas left, right? So the neurotransmitters are like the gas. They're the things that make the brain chemical, make the neurons work. But the neuron is actually the cell that's making this happen. So in a lot of patients that we work with, there's not enough dopamine neurons left, and the brain chemical levels are low. And that is a very bad combination, but we see that frequently. Right? And I just want to mention this one other thing, and then we can look at some of the potential solutions. You hear a lot about this. This is a process called methylation, and if you go to a lot of summits and online stuff, you probably have heard this term methylation quite a bit. But methylation is very directly related to what we're talking about, because you need to be able to methylate properly in order to make brain chemicals properly. And there's a lot of complicated physiology that goes into this, but the punchline is folate is really important for this to happen. B12 is super important for this to happen, and you need amino acids for this to happen. Okay, these are the key things. So I'll show you here in terms of methylation. And here you can see methylation substrates. And then over here, methylation products. That means what's happening, right? One of the main products is epinephrine, which was one of the more important brain chemicals. So if you can't methylate, you don't have enough of the B vitamins or amino acids, then again, you're going to have like a nutrient-related reason why this whole thing is falling apart. So, as with all things in life, it's a little complicated in that there's nutrient deficits that can cause this. There's inflammation that can cause this. We'll talk also about stress in a minute, because stress can cause this too. I'm going to show you here. So here's an example of a neuron, okay, that's being damaged. And when it's damaged, it can't send its signal very well. And I think about it like an electrical wire, right? A normal, healthy electrical wire sends signals. If the electrical wire starts to get rusty or old or something, or cut into, then it's not going to send the signals very well. And that can happen from physical damage to the neurons themselves, right? But then remember, on top of that, you can also have a lack of the brain chemicals because of inflammation and stress, which means that that damaged neuron doesn't even have enough neurochemicals to do its normal job. And that's where we find a lot of the people that we work with. And then what would happen, we have problems with weight loss or energy or mood, tension, focus, concentration. Those things aren't going well. People can kind of get into addictive behaviors or compulsive tendencies, OCD type problems, or just, feel tired, basically. A lot of people just tell me that they feel tired all the time. This is happening. All right, so I'm going to pause and take a few second break here, and we'll make room for a commercial interlude. So if you're interested in working with us, you should contact us because we have this amazing person named Jennifer who does free consults, and she is a board certified health coach, and we all love her. Everybody loves Jennifer. She's a really cool and smart person, and she can tell you about potential solutions in terms of the lab testing that we do, see if you might be an appropriate candidate for testing or not, okay? All right, now let's get back to the scheduled broadcast here. So let me just show you a quick test, and then you guys, I will pause again, and those of you that need to run off and go do something else can go do something else, and I'll answer questions at the end, okay? So let me just show you a lab and see what you guys can see what this really looks like. Here we go. Sample lab. This is totally random. I just picked this randomly, but let's see what it has. So one of the things that we're looking for when we're thinking about, oh, and I forgot to talk about stress. Let me mention stress first. So you can have no history of head trauma, no history of drug use, no history of prescription drugs that have depleted brain chemicals. By the way, most people that have been on antidepressants are going to need to have the brain chemicals rebuilt using nutrients, right? We do a lot of that work post, you were on it, let's say you got depressed, you took an antidepressant for a few years, you're no longer taking it, and you want to get, feeling better, you can test and put all the missing nutrients back in to get your brain to work properly. And again, I'm not against the use of antidepressants. I've had very close family members whose lives were saved by antidepressants. Sometimes you need to take them. If you're suicidally depressed, that may be the only option. But after the medications have done their job, we want to rebuild the brain, okay? Or if you've had a long history of drug use or cocaine or alcoholism, we want to, again, test your brain markers and rebuild them. Or if you have a toxin exposure, detoxification issues, again, we want to test and rebuild. But there's another important instance in this, which is that you can deplete your brain chemicals radically simply if you're under enough stress. And it doesn't mean that you have to necessarily be pulling your hair out and screaming all the time, but intense emotional stress will deplete these chemicals. And where do I see that? Anyone who's gone through a divorce is going to have some pretty serious brain chemistry depletion. Anyone who's gone through death of a family member that was hard, maybe you took care of your mother for 5 years while she had cancer and then she died, and just that intense emotional stress of that can deplete brain chemicals. So we do see emotional stress, caring for a spouse that has Alzheimer's, that kind of level of stress can also deplete brain chemicals. That's enough to alone to do it without any toxins, without any head trauma, without any drug use. That's enough. Okay, so I just want to run through one lab here, and then we'll look at questions. So on these labs, we can measure amino acids, and there's a whole section on here I'll show you that's specifically for neurotransmitters. And strangely enough, it's titled Neurotransmitters and Precursors. Okay, and here are all the amino acids from which you make your brain chemicals. So if tyrosine is low, we give you tyrosine. If tryptophan is low, we give you tryptophan. If taurine is low, we give you taurine. But you can't tell from symptoms what's low. So if you have low tyrosine and you go out and you take a bunch of tryptophan, that may or may not be a really good idea, okay? So be careful about that. So that's one way we can check. And then I'm gonna show you a couple others. They're super important. Now, if you're inflamed, there's some pretty famous ways that you can reduce inflammation. And one of them is using antioxidants. So here we have an antioxidant profile too. It's all part of the same test. So if you're inflamed, we can use antioxidants, put the inflammation out. And there's another famous way that people can treat inflammation, and that is if you have a deficiency of omega-3 fatty acids, fish oils, the EPA and DHA, then we can use those, which very, very dramatically affect the brain and reduce brain inflammation and help the neurons conduct signals better, and very, very important for people with brain-related issues, omega-3s. And then probably the most important special part of these tests, and this is an ion panel. We run this test on most of our new patients at my clinic, looks at the neurotransmitter metabolism markers. In this case, you can see vanilmandulate is very low. That's an adrenaline or epinephrine marker. And homovanillate is extremely high. That's a dopamine marker. So this person has super high levels of dopamine being put out and super low levels of epinephrine. That is going to feel like extra horrible. Okay, and so we'd want to lower this one down and bring this one up with a supplement program. It's a little complicated, as you can see. Like, what if they were both low? Well, the program would be a little different. If they were both high, it'd be a lot different. And here are the markers I was referring to earlier that are inflammatory: kynurenate, quinolinate, and picolinate. So these are the inflammatory markers, and these are the stress-related markers. So if these markers down here are high, we know you have inflammation that's impacting the brain. We got to change your diet and address the inflammation. And if these markers up here are either high or low, we know it's stress-related. Okay, so that's pretty handy. You can differentiate between stress-related brain issues and inflammatory-related ones. And the treatments are completely different. If it's inflammatory-related, we got to check your digestive tract and clean up your diet and get the inflammation to be reduced. If it's stress-mediated, then we have to think about things like meditation, getting you more sleep. Maybe you need some grief counseling and whatnot. Okay, so these labs really shed a lot of light on how to do all this stuff. And I'll mention one last thing just so you know. Many people with the neurotransmitter problems that are related to environmental toxins will have detox indicators that show up on their tests as well. So we want to clean out all the environmental toxins and get the brain working right. Okay, so it's very rare that it's just one problem. Usually we want to work on a series of different levels to get these kinds of things to get corrected. All right, so if you guys are curious about all this, you can check out a free consult with our board certified health coach. And you can reach her at kalishwellness.com. Just click on the free 15-minute consult and she can answer your questions about the labs and see if you would be a good candidate for working with us. And then in the meantime, let me see here. If there are any questions, you guys can let me know. Let's see, no questions for today. Oh, that was easy. Okay, I'm gonna wrap it up for today. Hopefully that was helpful. Learn a little bit about your brain, and we'll see you guys next time we do one of these. All right, bye for now.